Okay, we are live again after quite an interruption. Let me put you. So I don't know what I said at the end, the last episode, and we were. I was uh, changing the appearance of this website in order to read a little bit better, and then the internet got disconnected. Uh, It was intermittently. Uh, I was trying to get online again, and yeah, eventually we are back again. And while I was waiting for the internet to arrive again, I was thinking of this guy Israel Moisevic Helfman and his book series. He's thinking uh, how the intention of those books is for the people that were living in remote areas, some sort of village, rural areas, for the people where they were lacking some mathematical instructors, or very few. But uh, like even in the time, like 60 years in the future, I was able to enjoy this book. And that book in particular experimented a lot of hurdles before hitting the market. So I really want to deliver this application. It will not change the world, and I don't think like that. I don't feel like changing the world. And but I want for the application to be there. It's not a big deal. This thing can be done in 1 hour by an expert, JavaScript expert, some Canvas expert. Uh, well, again, I don't care. I want this to be available and then share the content of that book. So for the people, even maybe, I don't know, the future, things will change. Education will be delivered. Information will be delivered differently in the future. I suppose it will be injected right into your brain. And so, but perhaps there will be people longing to experiment, to feel and to live the experience of learning as the human beings that we are, as our species learn, as the human race. So there will be people in the future using technology to have the information in their brains. But some of them, there will be always people longing for truth. I have hope, as this guy says. Uh, and they will say, let me take a lot of time learning this and going through the frustration of learning instead of having the answer like this. I don't want that. I don't want that instant gratification. I would like to learn like the people in the past. Some other will say it will take you forever, and we need it now. Again, if they are working, they can do it. But other than that, they can engage. Well, I think that can also happen in the brain. They can connect it to something and for about 3 hours to feel how people learn in the past. But I don't think so. Well, maybe yes. Yes. I think it will be possible to experiment 2 years of learning in 3 hours of having some sort of a connection to any machine. I don't know. Mm, yeah. And This thing is for Veritas or more likely. Yeah, it will be possible without spending, yeah, a lot of time because. But then again, that would be cheating on themselves, fooling themselves because they just want to feel. They will be just wanting to feel, not the actual thing, not being. Let me be ignorant, right? They can say that in the future. Let me be ignorant. Let me learn by myself. Let me see by myself. Let me interpret the things with my own eyes, as the Apple says. I want to see with my own eyes. Let me be ignorant. And I don't want to know everything. I want to take the steps necessary to learn something, as people did. I don't know, centuries of years ago. I'm just being crazy here, just daydreaming, maybe saying a lot of nonsense. Most likely, I am procrastinating about this rotation of the image. Now that we are back, we can continue with the experience of learning the Canvas API in order to construct an application for projective geometry to draw constructions of projective geometry. And look at this. Mm, so there were these images that looks good on white. I don't know. So scale, resize, rotate, turns it around the origin. Okay. Scale resizes the canvas. The canvas. So there is the canvas and there is the context. It seems so. I don't know. Rotate turns it around the origin and translate shifts it to a new position. Most likely this will be the one. But actually, I'm different to what the three previous images. Just not the canvas as an object in the browser window is moved by any of these operations. Look at this. Not the canvas, as I just said. But if you're reading this right, resizes the canvas. So you're tempted to think, okay, resizes the canvas. There are two things. That's what I said. But then it says this, not the canvas. It resizes the canvas, not the canvas. As an object. Maybe there are two terms for this. I don't know. Not the canvas. It resizes the canvas, not the canvas. An object in the browser, as an object in the browser window is moved by any of these operations, but rather its coordinate system is altered. You know what? Probably should have take time to read about the coordinate system in, in the web browser, which we have here. By the way, this guy has a book on the methods of coordinates, and I was having a hard time with the second topic. I was falling asleep very late in the night. Well, not late in the night, but late like the midnight. So we have front end, and then we have coordinates. Perhaps we should have read this prior to. But you will be never ready. You need to dive in. Take a jump of faith. Leap of faith? I don't know. You're waiting to be 100% sure, 100% ready. Then I don't know. You will do nothing. Or maybe yes. I don't know. Uh, what is this? Oh, the table of content. Table of content. Below, we will demonstrate what that means in many examples. Okay, it transforms. Let's call these three things transformations. It transforms the coordinate system. The coordinate system is altered. Okay. Next to next to this, we don't have to become an expert on this. We just want to see the lines and the points, and that's it. Even if at some point we don't understand what happened, I will be okay. I don't know what happened at the lower level. I wish I know, but I'm starting to think that I will leave this planet without knowing the very elements of the computer. I don't know. I hope no and try to see this how this thing works at the lowest level. Next to these three special transformations, there are also the general transform, set transform methods, which are most powerful, but also more difficult to comprehend and apply. Okay, so let's keep this. Let's have this file. Let's leave this guy alone. These guys. We also show that any combination of transformations, first scaling, then a rotation, and finally scaling again, is itself a transformation and can be performed with one transformed code. The other way around. The other way around, this also implies that we can decompose a complex transformation into simpler steps. Okay, and they start with scale. I will not you know, stylize this. You can highlight this thing in order to be able to read. Canvas rendering context, scale. Let's read about this in Mozilla developer, this thing, and then go back. Most likely that's uh, the most direct way to implement our task. But now that we are here, I want to see uh, this page first because this thing was mentioned. And most likely is where is it? Most likely is this CDX. I intended to change this name. Okay, so the interface part of Canvas API provides it is the rendering context for the drawing surface. The canvas element. Properties from the tool described in the reference section of this page. The canvas tutorial has one explanation. Maybe we should have go the canvas tutorial, but mm, mm, yeah, I can take the entire day. I can start to reorganize my days a little different in order to focus on this for a for a period of time, then leave this thing alone and go up to another topic. uh, the off-screen canvas. Otherwise, random context, the off-screen canvas, then it's one of the okay, to get the canvas and context inside, you must first have an HTML canvas element to work with. So canvas ID my house with 300. To get the canvas to the rendering context, can't get context on the canvas. So yeah. So this is the standard. I'm leaving it like that. With context in hand, you can draw anything you like. This code as a house. Now it's beautiful. Look, I wish this thing just rotate the context and 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 the operations remain the same. Drawing a line. Uh, if the canvas is rotated, the context is rotated, so we don't have to come up with complex formulas or even to think about formulas like 2 days ago. That was really be able to understand the thing. The moving of the straight edge was quite a thing. I wish only thing remains the same. And yeah, so drawing text, drawing line, no more about. We will need text because of the points will have name. A, point B, line A, B, line A with the endpoints A, B, then some triangles. I can't believe some Spanish words appeared into my speaking. I don't know. Maybe I'm talking too fast. Uphill and stroke style, gradients and patterns, shadows, paths. Okay, give me some drawing paths, transformations, objects in the canvas rendering context 2D rendering context have a current transformation matrix. Perhaps we should review linear algebra. uh, there is some transformation, some rotation matrix. The transformation matrix is applied when creating the current default paths painted. The methods listed below remain for historical and compatibility reasons. Objects are used nowadays will be objects. The reason dogmatic objects are used in most parts of the API. Nowadays and will be used in the future if dogmatic was this. Rotation and translation. Red workers. I think I'm going too far. I think it should be easier. So here it is. Retrieve the current transformation matrix being applied to the context. So remain for historical reasons. So these things might will be obsolete. And since the new way to go is this, well, come on, then add some documentation. Yeah, but come on, does our image has this thing? Oh my God, we we don't have access to the things we have optimized, uh, being so cool about the code from the beginning. Now we are inside this document loaded. We are not able to access this variable anymore. So for the time being, I'm going to get rid of this. Now we can access the variable. Those have done matrix. Saying nonsense here. Okay, how we can access this matrix for this object? Um, done matrix. If you are only able to create a new done matrix, oh my God. Matrix. Four and elements. Blah blah blah. Okay. Come on, give me this compute transform. Get compute style. Compute style map. Compute style. Get compute style. Get element. Let's see what this thing is. Okay, nothing. Okay, nothing here. So this code does not work. Maybe I am too eager to finish this. Okay, now people are asking about this instead of the previous. I can't believe. Oh, get computer style. Oh, Windows. This thing belongs to Windows. I don't think there's nothing here. What's this? It's empty. No, we will use the. You can get, maybe you can become an expert in this. I will use the methods they use for legacy methods for historical reasons. Oh, here's transform. And everything is empty. Okay, so we have some matrix, but no, they only create okay, maybe no one knows. So it's, so we are tackling several stuff. But we have a canvas. Let's use the canvas to see if this thing works. Because I think this code just depends on the internet. And then you use some sort of AI assistant tools to give you pain for this code to be suggested. I'm not trash talking your bytecoding, coding, right? Because probably with that approach, I will be already playing the guitar instead of anything else. Okay, so let's. So we have a canvas. Okay, and now let's see if this thing actually do something. Oh, it only works with images. We can add an image to test this thing. So now, let's add an image. Uh, and we will call it oh my God, my image. Come on, just me. Wait, out, wait. We have our image. Now we can use the code as it is. Oh, but there's nothing. Oh, we didn't apply. We didn't set the ID. My bad. Okay, now we have. Now we have an image. Now we get to apply this. Okay, I don't know how this goes well actually. Let's be cool with this. Let's play along. Oh, so I got an error. I'm missing that. Oh, this thing. Why is this thing here anyway? There is something here. Okay, now I want to rotate this. Okay, matrix is uh, const matrix. No matrix. Okay. Well, uh, okay, we're back now. Rotate. This will do nothing, most likely, but the values at least should change. Okay, this thing changed. Uh, now, how can we assign this matrix to this element? Assign matrix to an HTML element. Red matrix, okay. Element state transform matrix. My Wow. Oh my God. But it's not that cool. It's amazing, but it will be like a nightmare to implement if it behaves like this. Because indeed the thing rotates by 45 degrees. I don't think this is 90 degrees, 90 degrees. But remember, we already applied 45 degrees rotation, so we ended with 90 degrees. Uh, we will need another session on here. Yeah, let's get started. First, we need the image element. Okay. Now we need this. Now the rotation. Okay. It seems to me that images can be drag and drop on the page, in all the page, along all the web, the viewport. Okay. We can only apply uh, uh, okay. Maybe we can create the image, attach the image to the DOM, make it the image hidden, hiding the image, the element visible. No, no, I don't remember. display none. Perform the rotation. No, that's too much. That's crazy. I'm just talking nonsense here. Uh, that's crazy. I can that be done. That's nonsense. That's silly. That's just ignorance of how this thing works. But as you can see, you indeed can rotate images with the dog matrix, which is the new way to go. And according to MDN, now that I'm seeing this, I think we can add something to our website. Something that looks a little bit silly, like in here we can add some images and, right at the middle and give the impression that everything is screwed in here. Like there is nothing. There is something, something cool, some images, some rotated images in here everywhere. Because now you're seeing that you can place. We will take. Maybe this thing can be. Maybe this thing can be moved. I mean, drag and drop everywhere. And if the user press over here with the mouse of the finger, then the canvas will be. But no, because look at this how it looks. We will do it again. We need to see this. So this thing is right at the left. Now we are computing 90 degrees to see if this uh, thing. Let me take a look at this because these guys implemented several points of rotations. Wha- Where is this thing being broken circles? I can't believe it. What is this? Oh, Advent of Code. Advent of Code 23. I was solving this. I will, year after year, I want to give a try to this problem. And remember this, I was interrupted. Uh, oh my, I can't believe how many interruptions. Yeah, so what's happening here anyway? So filter is digit maps thing, some sort of sum numbers. I don't have to retain this. I'm looking for I have something which I perform drawings, but now I can't find this blackboard. So I am blind. It was right here, and I was this way and didn't see it. Okay, so in here I'm going to rotate 90 degrees. Okay. I am doing this because I'm trying to see if the rotation happened at the center of the image in our case, because now I'm going to rotate 90 degrees from this part of the ruler. Look, this is 90 degrees. So the rotation is happening uh, at the center of the image, which is cool. Now we need to apply that to our object, to our image, and draw the image. But how can that be possible? How can we make that if we need draw image and we need to provide at least two coordinates? Uh, well, this thing works. This dog matrix, but we will do it with legacy method. I think we can have some sort of a short videos for my YouTube channel, using dog matrix to rotate an image. Okay, I'm going to get rid of this. Mm, okay, now back here. Okay. Mm, what is this anyway? Transform what? Uh, uh, maybe we can come up with some formulas. There's nothing here. Why this thing is not why we are unable to delete this? Okay. Oh, this is nonsense. This is not an HTML element. Uh, how cool is that? Yeah, this is not an HTML element. Yeah, we need to really uh, read about because this song matrix most likely is present for canvas and drawings. I don't think so. Maybe SVG elements, but not canvas. So, but the documentation says that yeah, this is for canvas. Look, canvas. Oh, most likely the CTX will have the oh my goodness. And we uh yeah, well, come on, this error is not it's arriving late because we have just used non-HTML. Oh, rule elements is this is an image element. Yeah. Now we can be sure that indeed image the constructor builds image element because it didn't accept the context. So that's great. What else? Yeah, tomorrow we will spend the entire day with this. Uh, so stay tuned. We will be like 12 hours talking nonsense. Unless we get interrupted. Not 12 hours in a row because I have to eat, have my meal. But then again, Don Matrix, it's here. So it's possible. The methods listed below remain for historical reasons and compatibility reasons, as Don Matrix objects are used in most parts of the API nowadays and will be used in the future instead. So let's take a look at we have in. Look, why in the world? I have a book here. Uh, why these people are doing this anyway? But the good thing is that I have a book on radians, on trigonometry. Of course, there is the internet, so you can. We can build a program. You know, I can I can read the book, the trigonometry book, and build a program in the playground to see. But first, I would like to know how these things relate to itself, the degree and the radians. So maybe some sort of graphics, some graphical visualization of the conversion, why it's taking place in the way it does. But that's in the future. Let's concentrate on delivering Geometrikap. What can we do? So the rotation of the dot matrix happens on the center, but there is a way to rotate on a given point. Again, no suggestions. Yes, because we don't have this. Oh my God, let's use canvas. You see, rotate from vector, rotate axis angles, rotate axis angles of axis angles. So there are more options, but we are interested in rotating the at the center. Maybe. Let's rotate at the center, but this is interesting. Now I want to know about the dot matrix, if it is the new thing to do. Let's do this quickly. This works. You can deduce this yourself by experimenting that and taking a look at the API. But if it is right here, it saves you like 3 hours, 2 hours, maybe 1 hour. I don't know. Okay, here it is, the formula. These guys are cool, you know. The rotation center point. Now I know what that means because of the book. Is always the canvas origin. To change the center point, you will need to move the canvas by using translate. Yeah, we will try different things. This is great. So, the for ourselves, for us, it would be this one. So, if we apply a rotation right now of 90 degrees, according to the theory, we should be able only to see the half of this straight edge in a vertical fashion. This will be vertical, and, and we will be seeing only the half of the straight edge. Let's try this very quickly. So, okay, where are the examples? So he moves uh, 45 degrees. So this is the center of rotation. So no, we will be able to see it. Okay, point of transform origin. Blue. This is to portray the origin. This one. Non-rotated triangle, the gray. This. And then they rotate the context. Look at this. 45 degrees. And they red and they apply. Oh, but they did this. Let's use the same. Let's use the same coordinates. And then in the future, what future? The future is now. There is no future. We should uh, maybe I will choose the web API to focus, because I will be trying to deliver more tools for the people. Mm, okay, we need to get rid of this. I'm doing it here because Let's do it from the very beginning without the event here. Yeah, we are doing 90 degrees. Let's not do this until the end. Uh-oh. Where is the image? We should rotate this. Let's rotate. Let's rotate this thing. Maybe because of the. Is it oh, it's repainting. That will be a quite thing to consider. What happened? Most events. Oh wait, we can delete this, and then we can see the effect of. Let's not draw the image, so we can isolate the thing. It's flickering. Okay, why? I don't know. Maybe this is necessary. It's necessary, but now the thing has gone. Should we use this? No, I don't think this is. I don't think this is the case. Oh my God, where is this? But this thing is. Let's not reset this for the time being. Okay, nothing is rotated. Even when we are. Where is this thing anyway? When we are draw image in the position, reset canvas. Reset canvas do nothing. And this apparently does the rotation. It should be, we should be able to see an effect. There's something going in here. let's let's not draw the rectangle. Okay, because we are not drawing any rectangle. Then we are drawing the ruler here. Then we say go. Then we are calling this early third of a second. We are resetting the canvas. That does nothing. Nothing. And then we draw this. This was nonsense. So it's not rotating this. This looks like 45 degrees. So why is actually doing this anyway? Uh, oh, why are we doing this? Probably we don't need to reset the canvas. Okay, okay, okay. Now we know why we are 100. Okay, this is not good because it should happen on the. This is so wrong, you know. I mean, this is a mess because There will be a lot of mathematics in here. If we manage to rotate this straight edge, there is no such a thing as rotating this straight edge. It's the context that is rotating. And if the context is rotating, these figures will be rotating too. And uh, unless we reset, if I use a draw a line, horizontal line, and then some rotation is performed on the straight edge, the horizontal line will rotate. Unless it is fine grained, we will see how to do this. And by the way, I need to take a look at the relationship of the radians. Okay, so this is the first image, and this is the rotated image. This is great because now this the straight edge didn't rotate. Now we need for this to rotate. So yeah, we will need to fine grain the position of this. And you have it. It is here. Now we need to take a moment to understand the point of origins of the canvas and of the context and how the transformations related that because um, the this thing, the rotation, I don't even know. Well, I know because I know the rotation didn't happen at the center of this thing because because if that was the case, the ruler will be like this. Here, look at the mouse. Okay, so the center of rotation happened everywhere. Elsewhere, happened elsewhere. Uh, I think it's here, but most likely not. Maybe yes. Look at this. Imagine there is something here. And then, yeah, okay, let me take a screenshot of this. Oh, we can do the annotation in here. Great. Great. No need to come up with. Oh, this is great. Oh, amazing. Okay. So imagine this is the rotation center of turn. We read the book live and we explain the rotation concept, turn concept. There is a point, arbitrary point over here. I don't know how how they select the thing. And then there was, they say that the rotation happens clockwise on the positive side. This is 45 degrees. Why? Because if it were 90 degrees, this is 90 degrees. You know that. You love mathematics, you know that. And someone will say, then why in the world this rectangle is not drawn like, it's not being drawn like this? Because this is not the center of rotation. This is the center of rotation. We need to draw an image. We will need a software to visualize this, to have a rectangle and some other rectangle inside, like this. And there's gazillions of tools that one can build for education. I can't believe it. And then rotate this and visually explain to the students uh, the concept, and they will see by moving this here. Um, you know, it is, you need to see this. Obviously, this square will not rotate on this because it needs to be inside of this frame. This rectangle, if it rotates on this edge, on this point, it will be outside, and in a way, it is outside. So maybe I am wrong. Maybe I am wrong. I was thinking that this thing, this rectangle, will end over here. Let me delete the other one. So there is like 1 centimeter. Okay. So, and maybe this is what happened because the canvas, the viewport didn't rotate. We are seeing this, but the rotation happened, but not, uh, I still, I don't think this is a model representing what's happening, but because if that's the case, if this is what the user is seeing, I'm sorry, I cannot see the colors that they are because of the laptop. If this is what the user is still, then the user should not be able to draw here. And if I draw now, uh, uh, let us check that. If I draw something at 200 pixels, according to me, my theory, it should be here. But if the rotation has taken place, then it should be here. And you will not be able to see this. Let's try that. Uh, I'm going to save this. So we did it. Now, okay, this is happening at, it's here, 200. This is 100. I'm going to draw a temporary one at 400, 600, 650. Okay, you're seeing this. This is 900, right at the end of this Geometrikap. At the end of Geometrikap, without the rotation, without the transformation, 900 is here. Now I'm going to draw this uh, this thing with the transformation applied, and we should be able to see it. We don't know. We don't know what is going to happen actually. Most likely we will be able to see it. No, now we cannot draw over here. Nothing can take place at this part because the 900 has moved. It was like here. The rectangle is something in your mind. You're interpreting the light, but it's somewhere that it's it is the rectangle. It is this is a question for you because we managed to do the rotation, but this is a question for you to think about until tomorrow. It is the rectangle. Does the rectangle exist? The one that we wanted to draw here, or does not exist? Just because you're not able to see it here, is the rectangle somewhere below the screen that you cannot able to look? Oh, let me take a look. Is the rectangle there or not? Somewhere. Is the rectangle somewhere in the world of your mind or not? Is this part of the rule of the straight edge? This part does exist or not? Maybe not because of the optimizations of the web browser. Maybe there's nothing happening here because the web browser maybe is deciding there's no need for me to draw these pixels because they are up outside the viewport. So I am optimizing for memory, for energy, and they don't exist. Those pixels does not exist. So maybe that rectangle does not exist. It's not painted. Okay, now that we have said a lot of nonsense, we have said a lot of nonsense. Now that the rotation has happened, I think it's now that we have verified that the rotation is indeed taking place from this part as they specified. Now we can mm, now what else we have verified now. Do we have a lot of work to do? Now that we verify that these things, the thread edge will rotate, but these things will remain. We can now focus on how to translate the point of rotation to the middle of this. That will be quite a thing because the user will be moving this. Look at this. Look at this. That's why you need to reset the canvas. Now you know. Okay. So that's great. After being interrupted for quite a insane amount of time, look at this. I need to have some meal. Yeah, we will continue this tomorrow. I'm looking forward to this because we will learn a lot of, of mathematics, mappings, because we will need to store these drawings and its coordinates in some sort of map, map of objects, so we can draw the entire map again. So it was cool. And we also need to take care of moving the center of rotation to the center of this image, and then resetting the matrix transform, the rotation matrix, transformation matrix. So for the people going to university and learning linear algebra, that works. It works as an intellectual stimulus for you to feel good, but it also, look at this, how it applies to computer graphics. Yeah, maybe linear algebra should be taught with applications and not being focused on theorem proving. Theorem proving or symbol manipulation, as some instructor says. Because you already did some theorem proving, hopefully, not me, certainly. When you arrive to linear algebra, you already did some theorem proving. So you know how to reason, hopefully. And then you know how to do symbol manipulation on matrices, because apparently that's being taught from high school. And then on university you can maybe track tackle linear algebra with applications, so you can see the thing working. And also some probing tuning if you are into that. I don't know who I am. Mm, This is an okay. In order to find the middle pixel of this thing, it will be t is between two and t is between t is over two, width over two, and height over two, and then we will have this the coordinates of the trans of the origin of the transformations, and then maybe keeping track of that origin point. No, we have this thing. No, will become a mess. It will be more complex than that. Could be, it will not be that simple. Can't believe I said feel. Come on, man. What's the point of this software anyway? Okay, that's our center of of rotation. I don't think so. Yeah, we have calculated this. We need to take care. Uh, yes, but this is the screen, the overall rectangle. If I manage to draw a rectangle, I was thinking that we will have width and height, width over 2 okay, but um, this point is not if this is 10 and this is 5, this point is not at 5. We need to take into account this. So this will be some letter A. So we need to come up with another problem to calculate the center of rotation. Let's use numbers at the beginning and then generalize. Okay. Where is this thing? Where is this point? To find the location of this point. I'm going to delete this. Um, uh, Yeah, we have this right. Okay, and now we can locate this point coordinates. Where in the world is this point located? I think it is the length of this. Uh, since there is 20, this thing is this. um, No, I don't know why I'm thinking of time. Uh, I think I don't know. Some people think that how you look is everything. Well, I don't know why I'm thinking of that right now, but I don't think that that's the way to go. And most likely this should be in the series sitting on the edge of Queen and chat and talk. Because this should be pure coding, no, not talk like I've been doing. That all this nonsense that I come up is to be placed on the other series. Because why I'm telling why in the world I am thinking of that for on the first place, and secondly, why I am telling I'm not focused. No, I'm not focusing. Not focusing on this. But now people, how do people look like on the everything? I don't know. Don't listen to me. I don't know why I came up with this idea. Uh, okay, so this point is 20 and y is this measures 10, so it is in the middle. So it is 20. In order to reach this point, we need those 20, and we need the half of the width of this thing, plus this will take me forever at this pace. And plus this width. Okay, so it doesn't matter where this thing is. Let's suppose it's here. Now it is 100 still. We will need 100. Or two. Uh, yeah, same uh, for the height. So we have a problem. We're going to save this. Geometrikap class sets. Uh, I'm very slow. I hope tomorrow reach more speed. Yeah, I think we're done for today. Yes. So I can play the guitar. Or, search for the Fender Studio app, which yesterday I was ridiculizing myself, um, because I was able. Um, this thing weren't working yesterday. I don't know why. The other day they sounded. I was able to play this. But now I don't know what's wrong with it. Maybe I should go at this. So this is nonsense. Okay, so this is not working. And then eventually I created this. There is there's nothing here, so I'm going to click OK. And again, I was very happy to see this, by the way. Look, this is great. And then apparently you can add some effects. Uh, so I don't know, all the effects. I think you can add more things here. Uh, yeah, well, I need to really spend some time, which is what I'm going to do next. Maybe I can share the live session of me exploring this. But I will be seeing lots of YouTube videos related to Fender Studio, so probably, maybe there will be some copyrighted material, so maybe not. Not a good idea, unless there is a manual for this, so I can share with you reading the manual for the time being. And thank you very much. See you at tomorrow to see if we can make some progress. I don't think we are going to finish tomorrow. Mm, no, I don't think so. No, I don't think so. Yeah. Thank you very